the fifth technical session of this 5 days training program on smart farming, application of AI, robotics, IoT, and cloud computing. So we will be having two sessions before lunch on the topic of foundation of artificial intelligence, and another one will be on use cases of AI and its hands-on demo. And both of these sessions will be taken by Mr. Nikhil Shah, who was with us in one of the yesterday's session. So without any further delay, I welcome and invite Mr. Nikhil to proceed with his session.
Thank you so much, Dr. Preeti, for the introduction, and welcome back. I hope I'm very audible.
Yes.
Yes, sir. Perfect. Thank you. So today we are going to start the journey on artificial intelligence. As I'm sure many of you would be familiar with it, must have seen various applications in a real world. Before we will talk about specific applications of agriculture domain, the first session would be primarily set the foundation for artificial intelligence, particularly for those who are perhaps new to the technology. Obviously, the goal is not to have you start coding, but to able to develop the appreciation for what goes behind the technology, how the mathematics, statistics, networking, internet, all are intertwined in developing the AI-based algorithm. So while agriculture is obviously a primary focus for these webinars, we will be looking at various parallel examples from other industry sectors also, so that you will have better appreciation for some of the new ideas, new ways of thinking, which may not have been obvious before. So allow me to share the screen and then we'll proceed. So we all know AI stands for artificial intelligence. I want to just clear some terms before we get into it. Many times people use this term interchangeably: artificial intelligence, machine learning, deep learning. Well, AI is a very broad term that explains the framework. That is not a one particular technology, it is just an overall domain. Machine learning is name given for a specific algorithms and examples and case studies, particularly mathematical models through which artificial intelligence is achieved. In other words, to have machines, computers, systems, basically non-living, computing power to think like a human, right? That's a broader domain which is called AI. How do you achieve the AI? Where you achieve the AI through use of machine learning algorithms. Okay, and many times you have heard the word called neural networks, deep learning. Now, what is deep learning? Now, deep learning is, you can think about, is a very specialized subset of machine learning. Deep learning is kind of getting more closer to how human brain is functioning or how human brain is making decisions, right? So deep learning is study about teaching the computers to think like a human, particularly for two kind of applications. One is image processing. Second one is text processing. Basically sighting, like eyesight, the vision, as well as the language processing. These two areas are very important, and this is how we humans interact with other humans, right? That we see things and we speak and we communicate. Either we communicate through audio or we communicate through writing or through facial expression, but all of that is, the vision is involved and the text processing is involved. So any problems which deals with uh, image processing or vision as well as text processing, they broadly categorize under the deep learning. Right? So that's just a, and I want to clear the some terminology and then we'll get into it. Now, if I want you to look at these images, and if I tell you that these people that you see in the image, they do not exist. That sounds funny, right? Or sounds scary, I guess. Let me show you something. I'm going to show you this image of a person. This person, this face has never existed before until just few seconds back. This image was created as we speak, right? Using, as you can see on the right hand side, this is one of the specialized advanced machine learning algorithms in deep learning with called GAN, Generative Adversarial Network. So this image is developed by a computer or by algorithms. Let me show you one other example. So in the whole mankind, we are approximately 7 to 7.5 billion people. This person has never existed before in the history of mankind. Maybe in the future could be, but yeah, so it is developed or generated using many or millions of human faces been studied, and different characteristics, different eyesights, the combination of skin, gesture, and texture, and many things are combined to develop or to create this image. Now, right? I mean, as soon as we start seeing things like this, our mind think both way, right? Many start seeing many opportunities, many would start seeing many threats or like a lot of security concerns, right? Which is valid. So obviously, we have seen in many Bollywood or Hollywood movies when we use or people misuse, I would say, the technology in a wrong way. But yes, it does open many interesting opportunities as well. For example, building some training videos more like a human, or maybe in some movie scene where you don't want a particular person to be identified, whatever is the reason. So this is kind of, I'm just wanted to expose you to various applications of AI that's coming up. Not only that, there are, in fact, you will be surprised this, if I say that this rental, the image that you see on the screen, this is not a photograph of a particular place in the world. This is all computer generated images. It's not an image of a particular location, right? So this is, 3-bedroom apartment close to a beach, which is just a description given. And from that, this kind of images are generated. Not only that, this is, I can tell you to so many other things. For example, some emotions that not existed, or this startup does not exist. So, I mean, this is completely new world that we are looking at. All right, let's come back to our stuff. Now, I want to ask you a question that everybody who is listening to, and if you can participate and just give me some inputs, I'll give you about a minute to think about, because I really want you guys to, or whoever is attending, or who are perhaps students and looking at artificial intelligence as a subject, I want you to go through some thought process. The purpose is, I wanted to see how our brain thinks, right? Because that artificial intelligence is basically giving artificial intelligence to a human or to the machine so that it can think like human. So we need to understand how our human process think. So I just put some 5 images on the screen. Those who wants to answer, if the moderator can give me some feedback. My question is very simple. What is the common among them? It's very open-ended question. The first one image is High Majesty Sultan Qaboos. He passed away recently. He was a king of Oman. In fact, our Indian President Shankar Dayal Sharma has taught him. He was a student in some past engagement. When President visited Oman, he himself has drove the car as a driver, like, as a out of respect for a president as his professor. Winston Churchill, I'm sure many of you know. The third image is about Sheikh Mohammed bin Rashid. He's king of UAE. Ian Fleming, those who may not know, he is the James Bond, the series, which is the brainchild of Ian Fleming. So he's a very famous name in the media circle or movie circles. And Katie Hopkins, she is a very famous name in the European circle as a very big media person. So I've just put some images. If anybody has a comment, I'd like to hear, or if moderator can, because I can't see the comments of the people.
Yeah, Mr. Nikhil, since yet, yeah, one is code. Comment is code.
Okay, okay, I see. All has some kind of code. I mean, I think they're referring to perhaps the cloth. I mean, the jacket. Well, perhaps I'm not expecting the answers like that. All looks human, or all are, of course, they are popular, but otherwise they wouldn't be here. But in general, if I wanted you to think deeper and from different perspective, the answer is perhaps not important. What is important is the thought process, how our brain start thinking.
Power and wealth. Someone had replied. Power and wealth. Maybe close to.
What did they say?
Power and wealth. Power
and wealth. Okay, so perhaps. Yeah, they are perhaps at least top three are some kind of leaders, political leaders, or the kings, but not the bottom two. Yeah, you can assume that perhaps they're rich, but we don't know exactly, right? A lot of famous people are not remain rich at the end. Okay, what I wanted to tell you that if I would have given this problem statement to a machine to think about it, I assure you that by now it would have come up with a couple of answers. You could have thought about that. Maybe are they all as born in
personality? Another one.
What is that?
Eminent personality, famous
eminent personalities. Okay, right. Okay, let me give you the answer. They all have studied at Royal Military Academy, United Kingdom, at standards, which is one of the very sought after school where all the world's, politicians or kings and everybody wants to get in. The point is, if machine or computer would have given this problem, it would have started looking at Wikipedias of the respective pages, of their respective Wikipedia pages, and start comparing one by one the parameters. See, some of the obvious things would have come on the surface, like what is their birth country? What is their birth year? Perhaps they all might have born in the same year, right? Where they have taken education, or what is their spouse names. I mean, so many possibilities. And the simple software project or simple software program written in Python language would have figured out by now, in just a matter of few minutes, that, yeah, seems like they all have studied at the same college or same college, same university, would have figured out, right? So is kind of, we wrote general software which to kind of help machines to start thinking like humans, something we many times missed, but the software written with a purpose would do the job, right? Okay, let's take few more examples. I hope this is all would give you the possibilities that's coming up with the you know machine learnings and AI. Again, I'm asking you to look at these few images, right? And if I ask you to predict, I mean, I guess you probably would know some of those images. Taj Mahal is obviously everybody know on the top, which is the temples in Palitana in Gujarat. This is Dubai's tallest building. This guy is Ian Fleming, but machine don't know, right? So we are all very used to search on Google. So Google is our encyclopedia for every little thing. I'm sure many of us probably would be using Google at least 10 times in a day, minimum I'm talking about. That's just integral part of our life. Now, what if I wanted to tell you that machine doesn't know, for example, right? I'm just wanted to do live demo of something. So let's say this is a guy. I'm just going to store his image. Like 1.jpg, something like some image. Now, if I go to Google, I'm sure some of you might know that Google offers many different ways to search. For example, I can do search using image also, right? I don't have to, sometimes I don't know what this image is about. So this is just simple Google. And rather than typing a text, because I don't know how do I describe the text if I don't know anything about that image. So I'm going to just upload some image here. The image which we just had it. Let's say somebody has given you some image that you wanted to find out more about. So this image is just a picture, and the file name does not tell anything. It's 1.jpg. I just uploaded the image and asked Google to search about it. Now see, within a seconds, it has come up with potential 834 results that possibly this person could be Ian Fleming, right? So now look at all this search that he come up with many images. Actually, all of that images of the same person. Now you can imagine that in a internet, there are trillions of images exist, right? The Facebook alone has about 2.3 2.8 billion users, like almost like 2.91 billion active users. That's by that measure, Facebook would probably the largest nation in the world, right? I mean, I'm jokingly saying that, but yeah, China is about 1.5 billion people or 1.4. India is about 1.3, and the Facebook is even more than combined India and China population in that spirit. So, in this billions of people are dumping billions of images on a daily basis. So you can assume that there is so many things are out there, but Google was able to come up with this search in a matter of seconds, right? How that possible? Right? So how that's possible? That's the power of image search. See, when I look at particular face, my brain would start thinking immediately, right? That have I seen this person before? Or we start recalling the so much of data stored in our brain, and after some time we might come up with exact match and say, yeah, this person is Dr. Priti, or this person is Mr. Kishore Kumar, or whoever, right? Or Lata Mangeshkar. Just by our brain immediately form that image and then able to give you some feedback in a matter of seconds, right? Now, teaching the computer to do the same, it's extremely difficult problem. And that is what been going on in the world of AI ML for last few decades. And this is a moment, this is a time where we see lots of advancement happening in world of machine learning. Okay, going back to our discussion. So that is what I was talking about, search algorithms. How so Google has obviously mastered the skill that for a given image in matter of seconds, it will come up with the uh, perfect fit for it, right? So the message here is, if you have any unknown image and you want to find out, the machine learning would help you. Or if you have a particular, and we all face this, right? If I hear a particular ghazal or particular music or particular song, but then I'm trying to recall that, hey, what this song, which movie was this, or who song this, who was the singer for this song? You want to find out all this stuff. How would I find out? I will probably go to Google and perhaps the wordings of that song. Sometimes we just hear the music, just instrumental music, and I want to find out what this song is all about or what this music is about. How would you type? You can't type anything on the Google. So you just upload that clip of a music, and the Google would tell you that what is the because it can also do the audio matching, right? Audio search. So that's all examples of AI in some way. So key message here is, as you can see in the image, many times I tell this that this is a image of ice hockey where you are playing with the puck. So this device, like a carom striker, this is in ice hockey, it's called puck, P-U-C-K. See, if you keep on chasing puck, you're not able to get it because in a matter of second, puck would travel from one end of the ground to another end of the ground in ice hockey. But we all know that the game of ice hockey, the ground is covered, right? The puck don't leave the ground; it hits the wall and comes back in the ground. Unlike the cricket or unlike the football, in this case, ground is covered with the the vertical surfaces so that it comes back. But it slides. It's so fast because it is on ice. So what is important that we should know where the puck is going to be, right? Where it when the person is hitting is going to hit this wall, is going to take this angle, and this is where it's going to. So all the smart players of ice hockey, they don't chase the puck, but they go towards where puck is going to come, right? And that is what these technologies are all about. That learning, machine learning, understanding of all the relevant ecosystem technologies is very important because the world is going that way. So we need to be there ahead of the time. So it's good to be cognizant about these technologies. Well, in this 1.5 hours and then next, basically next this and next sessions, we are going to look at this couple of topics. Just like what we are doing is just foundation topics, some of the terminology, what this MLDL is all about, different applications in a real world that we see AI is being applied. There are some ethical concerns. There are some bias, some concerns about job loss. So we'll talk about those areas. Then we'll look at how does machine or how does computer or laptop or server or some system or hardware, how they make decision, how we can teach computer internally, how does mathematics and statistics are used. I know I assume some of you are from statistical background also. Interestingly, I would say that engineers like me, believe it or not, we never studied statistics in a meaningful way. Yes, we know engineers learn mathematics, but as part of curriculum, usually statistics is a big part of commerce education. But for artificial intelligence, machine learning domains, statistics has a significant applications. So if you are really wanted to study machine learning, you would need to get the foundations of statistics very clear with correlation, regression analysis, hypothesis testing and all of that. We'll look at deep learning. We'll look at NLP, which is natural language processing. like chatbots and stuff like that. And then we'll look at some of the case studies in agriculture sector as well. Now, before we get into definitions and understanding of AI, let me also correlate with the real world stuff. Some of the fonts are small, but I wanted to cover this image, so I kept it. These are some of the sectors where we see, one second, let me hide this. Yeah. Okay, so these are some of the most popular domains of artificial intelligence that's being applied in the real world. If you look at, banking or insurance sector or finance, let me give some examples. And all these examples, I really wanted to cover, and I hope you understand and follow that well, because that would give you a lot of new opportunities, because you probably know agriculture sector much better than technologists like us. And for you to able to draw the parallels and able to come up with some new interesting use cases, let us look at some of the other scenarios. Now, let me ask you this question: that how does bank make money? Any bank. I mean, those who wants to interact and participate, feel free to put your questions in the whatever the feedback mechanism you have, and I'll request moderator to interrupt me and talk about it, but I'll continue. So basically, banking sector makes money by loaning them out, right? They give a loan, right? And if you put your fixed deposits in the bank, you will get probably 3, 5, 6% interest. But when bank give a loan to, hopefully to the right people, and not the Vijay Malias of the world, but or Nirav Modis of the world, who has run away from the country with thousands of crores of debt on their head. But banks give loan to businesses or to individuals at 10%, 15%, 17% interest. So there is a gap, right? Bank give money at 15% interest, but bank gives us, or the people who leave their money in the bank, they give about 5, 6%. There is a gap of 7 to 8 or 10%. And that's where the banks makes money, right? More or less. I would say bulk of the revenue is coming from this. So isn't that the most important decision for the bank is to make sure that the quality of loan approval process, right? The quality of loan approval process must be solid. If you are making the wrong decisions and you're making the wrong decision about giving the loan to the wrong people, obviously bank is not able to recover the money and there's going to be significant losses, right? So it's established that loan approval is the most important thing, and bank, we all know that when you try to get some loan from the bank would do the proper due diligence. They will ask you to give last 3 months of bank statements or last 3 years of income tax return, any other loans that you have taken. They'll check your CIBIL score. So many things they'll do, and before they will come up with the conclusion that look at your monthly income is about 70,000 rupees. You have 2 children where you're paying the fees, but you're trying to buy BMW, which costs 35 lakhs. The monthly installment would be 2 lakhs. Of course, bank is not going to approve the loan because your income is not suffice to pay your hafta or your installment. But there are many times the loan is been given for a right reason, or sometimes it's influenced, right? The bank officers could have been bribed or been threatened to get the loan approval, and human could make mistakes. But what if I say that if I'm the bank and I have last 15 years of history? When I say history means I have all the documented facts about in last 10 or 15 years, bank has given about 10,000 loans. These were the parameters. That means the borrower, co-borrower, their salaries, their bank average incomes. There are 15 different parameters. And then there is a documented fact whether the loan was approved or not, and then you also have a historical data whether loan was paid back or not. So this is nothing but historical data. What if I tell you that we can apply this historical data, the machine learning algorithms on this data, and then I can come up with a mathematical model which would tell me with 95% accuracy that whether new applicant should be given a loan or should be not given a loan. That means he should accept or reject his loan application. How? Because we have taught the computer using last 10, 15 years of data that past may we had taken so much of loans. This was happened. This was the parameter, and this many times loan was paid back. This many times loan was not paid back. So all this permutation and combination, the machine learning algorithm would learn that if these combinations are there, then loan should be safe. If these are some of the anomalies, loan shouldn't be approved. So think about that these algorithms are almost 90-95% accurate. Then bank management should rely on this kind of algorithms. How they would use it? And many of the banks have started using this. So they would obviously have loan officers, but if loan officers has some doubt about the decision, or management want to double check. So let's say some loan officer has approved the loan of 3 crore rupees, but bank management, when the amount goes more than 1 crore, they wanted to have a sanity check. They wanted to have double diligence on this. They can use this machine learning based algorithm where they will feed all the parameters of the loan applicants and ask machine to predict what is the success rate of this loan. And if machine says that, yeah, it is safe, or it is 90% probability that, or 95% probability that money would come back, then bank would have the second opinion, right? But if machine scores a red flag, it says that, no, this is very risky, only 40% chance, then of course bank would know, and then they will do further due diligence, because it's not possible to do this, thorough checks on each and every applications. Exactly same scenario you could apply into healthcare, right? Healthcare is one of the big applications, many such incidences where you would see that the AI ML is used, like in insurance sector or hospitality or entertainment workspace, you name it. Now look at this healthcare here. What if I take my neighbor to a doctor because a neighbor was complaining about chest pain for consistently for 2-3 days, and I've taken that person to a hospital. Hospital did the ECG or whatever the cardio reports they need to do, and they are telling you that, oh, there is a severe blockage and you need to be immediately operated. You can't make delay and things like that, and the hospital or the operation cost would be 3 lakhs rupees or whatever. What would you do? What would typically person do when we know that this situation happens on a daily basis in around us? See, people usually go for a second opinion. They will talk all the family doctor, or they will like to see some other opinion before you lay down on the operation bed, right? Because not only the money, but also nobody wants to cut the chest and do the operations for no reason. So whether you trust the doctor or not, you still wanted to get the second opinion. Now, if you go to the second opinion, again, it will cost you 25,000 rupees for all kind of tests and whatnot. But what if I tell you that the machine learning based diagnosis system can be developed, which can act like a second opinion, which can predict with reasonably high accuracy that for a given conditions where you can upload its reports, where you can put their health conditions, whether person was tobacco eater, whether person is living a stress environment, whether person has a hereditary, the family, there is a generations, they have a heart problems with their parents. You can enter all these parameters, and then machine can predict with all the thousands and thousands of historical data for this given parameter, the likelihood of heart disease is very high, right? So this second opinion can literally cost you nothing or very minimal cost to develop this model. Similarly, in a sports, right? These days, people are extremely intelligent algorithms are being developed that to guide the person, how they should make a shot, how should that improve their golf game, for example. And I'll tell you one very interesting use case so that you can draw some parallels from it. See, people go to gym, right? So let's take example of healthcare or sports. People, particularly young generation nowadays in India, is getting more aware about it. They hit the gym daily or few times in a week. But you notice that in a gym, unless it's superly expensive or well stuff, you wouldn't have so many gym or personalized trainers. So you will start doing weight exercise or different stuff. Many times people make mistakes. They pull the weight wrongly, or their hand gestures or the movements is not suitable, which in fact could harm person or muscle pulls rather than helping. Now, virtually, it's not possible for a gym trainer to be, serve each and every individual. So there are new startups coming up, which has recently got funded in New York also, where all the equipments in the gym would have camera and the screen, the large screen attached to every equipment. So, for example, if you are doing the weightlifting, they will be constantly you personally, the person who is doing the exercise, is being recorded, and using machine learning algorithm, they've been already been trained ahead of the time that the posture should be like this, right? And if you are pulling the weight in a wrong way, then it will immediately cause a red flag. Same thing could apply to Surya Namaskar, or that if you are, there's 12 steps involved for Surya Namaskar, and person has started doing it, and the fourth step is doing completely wrong, then this machine would immediately alert, and it will make a vocal communication, and it will also say that, hey, I think you may want to look at the correct pose is this, right? So this is a kind of personalized coaching experience. And that is with the image processing, that your constant exercise is being watched and compare with the previous training done, and it will tell you, just like gym trainer would be alerting you that no, this is wrong, you should do this way. Same thing what machine would be telling. Well, I won't be going into each of them. This is very exciting field, and cyber security, smart homes, defense, agriculture, obviously we'll be talking about it, like drone and soil fertility, or how much is the crop we're going to yield and next year, looking at the historical data. Lot of guidance can be given to farmers, so on and so forth. I'll take one last example and then we'll move to the next topic. Let's take example of real estate, right? And that is actually quite relevant to agriculture sector also, right? We know that in last couple of years, we see the lands, agriculture land also in rural places like Sanand in Gujarat, or you name it, the price has gone exponentially high, right? That is gone from a couple of lakhs rupees per vigha. It has gone up to 20 lakhs, 25 lakhs per acre and things like that. So it has gone in 10 folds or even more in last few years. So real estate sector in Ahmedabad or Mumbai or Dubai, if you want to predict the price, that what would be the 3-bedroom apartment price in Naroda area in Ahmedabad, how much it cost, or how much is the land closer to Anand Agriculture University in Anand, how it would cost in next 5 years. We can use machine learning algorithms. What we have to feed? We have to feed last 50 years of land price increments, right? From land registry department, and we can ask machine learning algorithm, which is kind of those who have studied statistics. You can think about that as more or less a regression problem. So with linear regression or multiple linear regression, you can apply to even predict the stock prices. Same thing could apply to agriculture commodities, that looking at last 50 years of data, what would be the price of wheat or rice, right? So I hope that you get the perspective. Right? Any questions so far? If so, please interrupt me. I'll move on till that point.
Yeah, Mr. Nikhil, would you like to take question at the end of this session or in between the session? Is it okay to?
I'll leave it to you. I mean, if it's something really relevant, you can interrupt me. Otherwise, we can go
Yeah.
that.
So I would suggest you just complete your session. Then we will take the question from audience.
Sure. Perfect. Okay. Now let's get into AI now from different angles. What you see on the screen is the image of big data. When I say big data, see, big data is a IT computer science term, which is very common these days. Big data analytics, big data. Big data is an IT term which is commonly used in the IT culture. It literally means huge data, lots of data. To give you perspective, by end of 2020, the total data in the world is approx 50 zettabytes. Now we all know KB, right? 1 KB is 1000 byte, 1 megabyte is 1 million byte, that is 10 raised to 6. 1 gigabyte is 10 raised to 9. 1 terabyte is 10 raised to 12. This zettabyte is 10 raised to 21. This is ridiculous amount of data. And we all know, right, that people has a habit, you just record you take photographs from your image or from your phone. If the phone resolution is 20, 25 MB, in matter of 5 or matter of 30 seconds, you might be taking 10 pictures, because some of the people just have a habit of taking it and then they dump everything on their WhatsApp group. Imagine that 20 MB multiplied by 10 photographs, which would have taken in span of 30 seconds. So which is 20 MB times 10, which is 200 MB, 200 megabits worth of image that you could upload onto Google Photos, or you send it by email or by WhatsApp. Of course, WhatsApp would condense and shrink those images. But my point is that people load internet with tons and tons of data every seconds, every minute. So this is how we are processing this data. If the data is without any usefulness, it's just image, right? People look at the image and just throw it away or delete it. But it does cause a lot of stress on the internet, on networks, on communication networks and everything, on your mobile networks. But important point that many times we see the data on the surface. That is what we in the movie of Titanic, if you've seen that movie, this iceberg, they saw the very tiny iceberg. Those who have seen the Titanic movie, then would correlate what I'm talking about. You will only see this top portion, but in reality, 80–90% of the iceberg is not visible. It is under the water. Similarly, many organizations, they see the data, but we don't realize that how much is the data that is generated within the organizations, within the companies, or in agriculture sector, or you name it. And you must use some automation technologies such as artificial intelligence to process this data, because humanly it's not possible, it's impossible to manage this data and to be able to make actionable decision. And that is why I would like to say that we briefly touched upon it yesterday, but I call it data as a new oil, right? Why I say so? See, in the history of mankind, we have all has evolved, or mankind has evolved, Earlier, all the exchange was happened with the barter, then gold, then some diamonds, then precious stones, and then countries have started printing their own. First it was with coins for many years, for hundreds of years, and then the currency came in, like Indian rupees or Indonesian rupees or US dollar or Chinese RMB or Russian ruble, whatever. So these are the currencies, and then US dollar has become dominant in the world. But we know that last 5 decades or 6, 7 decades, we know that most of the wars in the world, perhaps I can't make this open comment, but internally, or a lot of people perhaps would agree that there is some kind of oil uh, or controlling oil mines or oil fields was perhaps could have been reason for wars. So oil is going to be the new currency in the world, right? This is oil is going to uh, control the world economics in a way. Uh, so why my point is data is going to be the new currency in the world. Not, in other words, the diamond is a precious commodity. Similarly, in going forward in coming decades, the historical data is going to be the new commodity, new currency, or new wealth, I would say. How? The machine learning and AI is going to be very important factors. Just like you extract, the refinery can extract the valuable commodities from the crude or from the raw oil. It can segregate the diesels, dammer, petrol, all of that. Similarly, machine learning and artificial intelligence as a domain, they have a power to segregate valuableness out of the data, right? That's why we call it new refinery, right? Because it can help you to make actionable decision from the data, because data is virtually infinite. It's just keep on growing. Similarly, 5G is a new transport. That is, I just want to highlight that communication network is very instrumental for future artificial intelligence algorithm to work. Because you make a decision, very classic example is a driverless car, right? I'm sure you must have seen many videos. A couple of my friends, I lived in US for almost 14 years. I moved back to India in 2009. A lot of my friends are still in US, and I'm sure many of yours too. And one of my friend bought the Tesla a couple of months back, and he sent me the video where he's on the highway at the speed of almost 80 kilometers per hour. Uh, the of course it has a steering, but his hands are not on the steering. The Tesla car is able to overtake the truck on the national highway in US at the speed of 80 kilometers per hour. It makes the own decision, right? It makes the decision that how much is the truck which is ahead of you, what the speed it is going. It also look at the cameras on the side, whether is there any other vehicle on that side track or not, so that do I have enough time to overtake and again come back to the lane. So all those decisions are taken by the car automatically. So a lot of those decisions are obviously taken using machine learning, but input from the camera, just like input from our eyesight, is important, right, to make this decision. And communication with other part of the network. Let's say some accident happens, and now you want to inform, you want to inform the hospitals or 911 or emergency services with the location, right? So all that information, you need a very powerful networks. And that's what the 5G is going to bring on the table. And blockchain is another very powerful technology, which is, I think, touched upon it briefly yesterday during my talk, that it brings immutability, transparency, and the traceability. Right? That we talked about it yesterday. So I'm not going to repeat that. So blockchain is another new phenomenon for a new trust or new settlement in the world. So these are all disruptive technologies or disruptive forces are happening. And that's going to make a lot of transformation in how we come up with the new business models. Okay. So our Prime Minister is also quite bullish on AI, artificial intelligence, and machine and blockchain technologies, particularly in the agriculture sector, right? Okay, so let's look at a bit of history, because history tells us a lot. Just like I was keep telling that historical data, it's a very valuable commodity. Similarly, understanding little bit of history of AI in just next few minutes, I think it will give you some good perspective of how things has evolved. Well, back in 700 before Christ, 700 BC, there was a coins like this where this was actual coin of so many years back, so many centuries back, where it has imagination of person with flying like a bird, right? So even before machine learning is kind of current domain, current technologies. Well, self-driving car is now becoming reality. People has already kind of imagined and on those lines. But let's come to recent years. In 1950, Alan Turing, he's published some very phenomenal paper, white paper, research paper, which has speculated the possibility of machines to think like a humans, right? So that was, so a lot of people consider Alan Turing as a father of AI. But if I continue, Christopher wrote the checkers game for, like a chess kind of thing, that how we can write a program which can basically algorithm, right? That can think like human. This term that we are using today, artificial intelligence, actually the term is published, or first time it was used 1956, right? At one of the Dartmouth very famous conference where John McCarthy actually coined this term artificial intelligence. So the terms is existed long back. In 1959, MIT had a AI, artificial intelligence lab set up. So where the real research started to happen. So you might think that this AI is so much of buzzword, but yes, it is a buzzword, but it is been going on for last many decades. If I fast forward to very recent year, in 2011, IBM had a program called Watson. Some of you might know this. There is a game called Jeopardy, very famous game. I know, let me quickly show you a quick example so that. So this is, let me make sure that audio is visible. Basically, the game of Jeopardy, right? I'm sure many of you would have seen this is a very, very famous, like Kaun Banega Crorepati equivalent, popular in, it has been running on US television show for many years. So this is called Game of Jeopardy, where these are some of the brilliant, world champions of Jeopardy. And now IBM Watson, this is literally 10 years back, right? IBM Watson is nothing but artificial intelligence driven computer, which also participated as a one of the Jeopardy player, and this is very landmark example that
first game I thought was phenomenal.
So that that Watson was able to beat the world champions. So Watson is just like acting and talking like a human, but he's using the internet search capabilities. Basically, whatever the learnings he has learned over a period of years. Just like human, right? We learn a lot of stuff, and then we go to games like Kaun Banega Crorepati, and then based on our intuition as well as memory, we answer. Similarly, Watson was able to, whatever the things that he has learned, and was able to participate and win. So basically, human was beaten up by the computer. And that was a very big landmark thing. If you fast forward 2011 to 2020, there is a lot of new innovations has happened, like a Siri in Apple, which is you can talk to Apple phone. Waymo is very popular robots, home cleaning robots, where you can just give a floor plan and it will automatically go and clean up the floor. Some very interesting algorithms like YOLO. Let me show you a quick clip about YOLO. I think it will give you a lot of perspective, and you will be able to see how it is quite relevant to our agriculture sector as well. Just give me a second. I'll share the screen. Yeah. This is YOLO is nothing but one of the very one of the popular algorithms using artificial intelligence, which is used for object detection. Dr. Preeti, can you confirm that you can hear the audio as well?
Yeah, we can hear. It is audible.
Okay, thanks. See that live feed of the road or for a particular situation, the machines can segregate so many objects simultaneously, right? So from this, it has labeled this from live video, this object as a car, this object as a person. Let's take a few examples. Here it says truck. It has started labeling different objects. Like this is skis, or this is a person, or this is a dog. Do not let this play with my mind. But when the boys from out of town. Now, see, there's so many objects are being like including the ball or cell phones and persons. What I'm trying to tell you that with a given training, we can use AI to do amazing things for us, right? Such as out of many substance, I want to segregate particular plants, or if I want to segregate particular disease, I take image of a particular plant and I wanted to find out, because see, all farmers probably not that literate. You wanted to give them some simple mobile application, which they can take the photograph where they find something suspicious, and instantaneously they will get a response. So their interface would be mobile, where they take an image and then that image would be processed on the cloud using machine learning algorithm, and it will immediately give them a feedback that, look, at this could be this particular disease, or this could be fungus, and then there could be a recommendation that maybe to mitigate this problem, you can apply this fertilizer or this pesticide or this in a combination of this, and it can be given in a Gujarati or Marathi or Hindi language. All of that can be very much possible, right? And how that is possible? Because we have trained the computers with historical data. There are 20 type of different diseases, hundreds and hundreds of images has been taken and has been fed into computer, has been trained that when you see this kind of image, it could be like this. But if you see this image, but if this also exists, for example, if you find yellow dots, but at the same time it is also along with the blue line or black lining, then this could be different disease, right? Again, I'm not the expert in agriculture, but of course I've studied a bit while talking to different people and clients. But for us, for the technologists, we just give us image and we'll train accordingly, right? And but you guys would be able to correlate in much different way. Okay. So that was about object detection. So there are a lot of innovations are happening in this space. Now, let me put one funny image here. We all know what is this, right? So if somebody is using this in his home, but somebody is, let's say, going into, or somebody is extremely rich person and having a gold toilet. But that's okay. I mean, we have heard stories that some very rich people in Dubai or whatever, right? The kings has a gold-plated toilet. The point is, this is, what do you think about this? If I say that your future, this is the future toilets, not that the transparency is important. What is important is the tagline that I've saying, what I've written on the top, how the future is going to a drain. It's not in a negative way, but it is used for the waste that person produce. It can offer you immense valuable data about that person's health, right? We all have experienced that, you know, your blood test, if something goes wrong, immediately the doctor would ask you to do the blood test and the urine test, right? For the measuring the sugar or many harmful substance would be caught up into the urine. What if we have this device which is obviously collecting the waste, but before it's completely thrown away into the gutter or into the garbage, it does perform the test and it keeps the historical data on a daily basis, isn't it? That, yeah, that even before the health get deteriorated or something happens, think about that as a preventive health maintenance, right? That if they notice that the sodium level is increasing for last 5 days, or something, or it detected the blood in the stool sample, right? Then something is wrong in the body, right? So before the symptoms really appears, this kind of a future toilet would help you very valuable information, right? Because it contains very valuable data about our body, right? You know, even the stool and other stuff that contains almost 75% of the water, it can detect so many things about protein, live bacteria, undigested foods, but it can be examined for blood, fat, fibers, bile, white blood cells, and all of that. That could be very extremely valuable for decisions. All right. So that's the, you know, interesting angle, and same thing could be applied for livestock or cows or bulls in the farm, where with technology samples you can or, you know, routine measurement, they can be checked for their routine health, or if some symptoms are getting developed before really it surface. So preventive maintenance is always better than post maintenance. Now, this is very interesting angle that I wanted to highlight. Some of you might know about Moore's law, which is a very famous law in the computer science, that every 18 months, every 1.5 years, computation power in the computer is double. That means the chipset, transistors, and it has consistently been proven true for last few decades. I don't know recently, but when I was in the college, Murray's laws was consistently was to be true. Almost at every 18 months, the capacity of the computation power or the chipset, the transistors was getting double. But this chart is slightly different. What we're talking about here is the calculations per second for every $1,000. Again, how many calculations that computer can achieve in a second if you are willing to pay $1,000 price, right? So this is back in 1990s till 2020, right? Earlier it was, electrothermal chemicals kind of stuff, then solid state, then transistors has been designed with the vacuum tube, then actual transistors has been invented. As these things were happening, the size was getting smaller and smaller, right? And then IC, called integrated circuits, came about. And today's when you buy laptop with Apple chipsets or Intel i5 processor or AMD Ryzen processor, in this tiny chipsets, you will get millions of transistors integrated, or that is integrated circuit. And now the future computing is optical quantum. You must have heard term called quantum computing, right? Quantum computing, there are a few companies like IBM, Google's are working on it, which has exponentially almost million times higher computing power, million times more computing power than today's computers. So that is the future. And this is how our, we are getting much closer to our thinking capacity of our human brain. With that, let me just talk about industrial revolution, right? That industrial revolution 1.0 was more about steam power, mechanical improvements. The industrial revolution 2.0 was more about mass production, assembly line, electrical energy applications, and then use the power to do automate the productions in the factories. Industrial revolution 3.0 was more about electronics and computers. And the current generation where we are right now is called industrial revolution 4.0. It is called cyber physical systems. That is the name of official name of 4.0. It involves so many things. It involves IoT that we talked about yesterday. It talks about computing power. It talks about networking. It talks about storage. It talks about security. And it obviously, when we talk about compute, it means computation power with machine learning and all of that. So combination of all this stuff is bringing so many new revolution, either in manufacturing sectors or many other sectors. So that is the industrial revolution point of view. Just to give you a very simple example, one of the problems that we are currently actually solving at the moment is this is the image of the circular knitting machines, right? Gujarat being the textile horsepower of India, there are, I would say, couple of hundreds of such factories, or maybe more, would be there across Gujarat, where it is basically automatic knitting machine, where the thread is coming from hundreds of such bobbins, and the threads are getting interwoven, so that fabric is getting produced. Now, many times what happened that because of some needle break, there are almost 2,000 needles are working simultaneously. If some needle breaks happens or some thread is broken, then you will see this kind of minor damage happens in your fabric which is being produced. Now, if this kind of failure goes undetected, that entire production is get rejected by the client, because it has to be perfect, because they're paying premium price for a particular fabric, so they won't accept this as a any defects like this. So can we use machine learning algorithms to teach the machine to look at the images and the videos, and whenever it finds anything abnormal, immediately stop the machine. Because when you have hundreds of such machines, you can't, it's running 24/7. Deploying the humans on every machine 24/7 is first of all not practical, and second of all, it's obviously costly, and human gets tired, right? You can't sit for 24/7 just looking at the stuff. So that's why we need machines like this. So this is a problem we are solving at this as we speak. So I thought I wanted to share some of these practical examples. So this is one of the work we have done some time back for one of the client, where they wanted to develop application which is using machine learning algorithms. So basically, I can take image or video capture of my feet. The machine learning algorithm would automatically put the contour line and identify some 15 different points like these red dots. And then using the red dots, out of hundreds of shoes are available for selling. Suppose I like this particular shoes, right? It will, in a real time, it will superimpose that shoes. Again, everything is happening in a mobile app, not a real one, right? So let's say I went to a particular store online and I wanted to purchase the shoes. But you wanted, see, in a real shop, you will be able to go there and try it out. You will be able to try that shoes in their feet, and you will walk around a little bit, and then you make a call. But on online shopping, that's not possible. So this is something they wanted to develop, where if you like particular shoes and you selected it, now you want to try it out. So you move your leg. So similarly, shoes will be superimposed on your leg and it will also move. And this is a very complex problem to be solved with machine learning, but that can give you experience, right? That many shopkeepers cannot afford to have a large shop setup. And many times people don't have convenience to go and do this, but they wanted to shop something. They use, this is a new way of shopping experiences are happening. Right now, I'll tell you some other example. Typically, what we see in the office, where let's say some employee is working in the back office in the account department. What is this day look like? It will go to the office, grab a cup of coffee, and his role is to invoice processing. So let's say this is one large company where they deal with hundreds of vendors, and different vendors send their invoices for whatever the goods they're supplying or services they're supplying. And this finance department has, like, say, 4 or 5 employees. Their job is to process all these invoices. So they will open the invoice, they will enter the data into Excel or in some database. They will make sure that GST has been properly calculated. They'll make sure that the date is proper, whether the signature is proper, whether GST number has been written or not. Basically, they'll make sure that calculations, total, everything is in place. And then they will, after doing all this data entry, they will pass this data to the supervisor, who will again double check this data. And then it will send to account payable department, who will approve, like, say, this person should be paid 2 lakhs rupees for, and they will issue the check. One second. Now, this is a simple process. Isn't that looks very boring? That day in, day out, for last 10 years, a person is doing exactly the same job. What I'm telling you, that these jobs are at danger. Almost 1,200 large corporations has already adopted the solutions where some kind of software robot is not an actual robot, it's a software process which takes care of this kind of jobs, where it will scan the invoice from that image or the PDF. It will automatically pick up the right field using OCR, optical character readers, technology, which is based on AI, and then feed all this data into the relevant Excel file or in a relevant software. Does the calculations, make sure that everything is correct, and then automatically send email to the next person for approval process or for the payment. So the job which was done by 4 people in the back office would be done by one software process in a matter of hours. So rather than 4 people working 8 hours a day, this process or this bot would be doing exactly the same thing in 2-3 hours, equivalent work of 4 people, and with a lot more accuracy. And that is the word called RPA. Why this is relevant? For all repetitive, mundane, and error-prone tasks would be taken over by something called RPA, Robotic Process Automation, which is highly driven by artificial intelligence, where all this stuff, like this is just symbolically, I have drawn this bot, but in actuality, it is a software process which is trained to read these different invoices, and then it will do exactly the same thing which humans are doing. So some people might wonder that, yeah, this is an ethical issue, that these technologies are taking over the jobs of the people. What would happen to their livelihood? These people would be let go, right? Because this robot would be much cost effective, and it can work 24/7, right? Because the person needs to go for a coffee a couple of times. He needs to obviously go home at 5 p.m. in the evening. The bot can work 24/7. So we'll talk about some of these ethical challenges of AI, if you think that way. But whether we like it or not, this is happening. The trend has been picked up. A lot of CFOs. This is just one example. I can tell you another 20 different examples of how RPA or robotic process automation. Basically, it is converting the repetitive processes with artificial intelligence. Well, the key message of that, I just to conclude this topic, the general summary or general conclusion, I would say, about this discussion that we just had, that people need to upgrade themselves. If you keep on doing the same thing year after year after year, most likely those jobs will be replaced by machines in coming years, for sure. At least I see that way, because it's much more economical. But that doesn't mean that people would lose the job. You need to upgrade yourself to handle the jobs which are less repetitive in nature, where the IQ or some human brain is used. In fact, many new jobs will be created by AI sector, and that's a very interesting angle that I wanted to highlight. So allow me to share one interesting use case so that we can address this topic. Okay, just sharing my screen again.
Gas pedal.
Marie Porter has been a professional driver for a decade.
I get to travel around and see all.
Let me give you the context. Mary is a real person. She is a truck driver in US for many decades. US being import-driven economy, a lot of stuff in US came from China, India, many parts of the world. You don't see much of manufacturing in US. In fact, a lot of recent election in US has gone with a key message that produce local. That means they want to bring local manufacturing back into US. But US being import economy today, even US flag is getting printed in China. You know what I mean, right? So US need a very powerful road system. They need extremely powerful, extremely well-connected railroads or regular roads or airports and stuff like that. In fact, in US, the total population of US is about 330 million people, which is about 30 crore, 1/4 of Indian population. Out of 330 million US population, almost 1%, almost 3.3 to 4 million truck drivers, which is quite a big number actually, think about it, because there is so much of demand, because the trucks needs to travel from ports or airports. They need to carry the goods all over US. So driver like Mary, they spend large part of their life, decades, it's a 30, 40 years on the road, right? Of course, I've seen that the truck driver conditions are much better. They are well slept, they not overworked in US, but in India, we have seen many times those guys are, drive the trucks for days sometimes because of extreme pressure that business has. Anyway, my point is different, that when you have 3 to 4 million, which is 30, 40 lakhs of drivers are driving the trucks on the road, when the new generation, like people of 20 plus years, they don't want to do this job. So in fact, the truck driver is one of the most sought after job. I wouldn't say sought after, I would say unfilled jobs. In fact, in Europe, in UK, a couple of months back, there was a truck drivers went on a strike, and because there was not enough truck drivers, and the traffic jam happened for days. Point is, new generation don't want to do this job, which is highly demanding, and you stay away from home for months and months. So she is getting retired, but she got a new job now, which is probably 3 times more paying jobs than what she retired with, right? When person retired, obviously his or her salary is quite high, right? Because you have accumulated salary increment for many years. So she's getting, after retirement, she's getting 3 times more salary. Let's see why.
Kinds of things.
But today, her drive is a bit different. See, her truck is in Alameda, California. And she's at a startup office in San Francisco, driving the truck remotely.
It's kind of like playing a video game.
This remote work may be all that's left for human drivers if robots take the wheel.
I think it's the future.
So you got the point, right? That she is sitting in San Francisco in one of the startup company, and she's actually driving the truck. How? She just have a real look like a steering, but whenever she turns the steering, it actually communicate back to the truck using 5G technologies or 4G, 5G technology, and she is seeing in front of her computer screen what the truck is seeing. Basically, truck is loaded with a lot of cameras in all directions. So Mary has a complete view as if she would be sitting in the truck, right? So she's not getting more salary just for driving the truck remotely, but she is one of the engineer. She's got the job as a machine learning trainer, because there is a new field is emerging called driverless truck. In fact, a lot of people are saying that driverless truck is more needed, or it has a more convincing business case than driverless car.
But what kind of future will it be?
As this technology unfolds, it's going to be extraordinarily disruptive.
Self-driving vehicles may make traveling down.
We came out of this.
I'm using that side mirror to...
Porter drives for Starsky Robotics, a San Francisco startup with an ambitious vision of the future of trucking.
We came out of this from the gate hoping to make trucks drive without a person sitting in them. That's why what we're doing is we're making trucks autonomous when they're on the highway, but teleoperated or remote control off of it.
Starsky isn't the only company trying to cut costs with autonomous technology. Last year, Wired rode along with startup Otto as it made its first autonomous delivery.
Yes, this is a
And
driverless
companies
truck.
like
Real
Peloton and
in
Volvo
the
Trucks
testing.
are also working on platooning rigs together for efficiency. Trucking, with its long stretches of autopilot-ready highway, may be the first part of the driving industry to be automated at scale.
I personally wouldn't want to be a truck driver.
Going to have
Taxis to trucks, employees need
Lifestyle. It's not.
night.
It's a hard life. You actually have to maintain a large vehicle over the road for 3 to 4 weeks, even a couple of months at a time. It's definitely a lifestyle. It's not just a job. Good morning, Internet! Good morning, Internet.
Knight has parlayed her driving time into a side hustle as a YouTube vlogger. She's cautiously optimistic about the self-driving future.
I'm in.
So I hope you get the idea, right? That this is the future. You can imagine that a lot of such vehicles can be driven and been trained. So the retired truck drivers is getting new jobs, because these trucks, to work smoothly, you need a wealth of experience that Mary has acquired in 40 years. That in a given situation, when should you overtake or should you not overtake, right? All that kind of decisions should be taken, and that's how the truck is being trained. So as a new AI trainer, she's working with the software engineers to train the machines, and that is the new jobs are now coming in the surface. So experience is not lost, but experience is transformed. So yeah, I guess let's stop for now. We'll continue more things in the next session, but if you have more questions, we can take it now or we can take it in the next sessions.
Yeah, can we take a few minutes break, Mr. Nikhil? Would you like?
Yes, of course.
Yeah.
I need a break.
So, dear participants, we will resume back right now 11:28 a.m. in Indian Standard Time. So we will resume back at 11:32. So take a 4-minute break, and we will be on the another session, which will be on the use cases as well as some hands-on demo also. And the question part, Mr. Nikhil, we will take at the end of the second session.
Okay, sounds good.
Yeah. Mr. Nikhil, are you there? Okay, Mr. Nikhil, can we start the session now?
Just give me 1 minute.
Yeah, please.
Yeah, we can proceed.
Yeah, go ahead.
Dr. Preeti, I'm ready whenever you are.
Yeah, Mr. Nikhil, go ahead.
Oh, okay. So welcome back, team. Let's continue our discussion with the foundation that we talked about with AI, number of use cases in various different industries, how it works, what are the key topics. And next hour and a half, I like to divide session in two different ways. One, we will expand on the real working of it, right? I understand that most of you are not engineers, but at 10,000 feet level, I think there is enough curiosity would be developed where we wanted to understand that how internally it works. There are some next level of jargons that we will talk so that we understand that, okay, this kind of problem is solved better this way. Some disease detection problem can be solved better with deep learning. So just getting better acquainted with the real working of machine learning algorithms, that is where we'll spend. And the second part of the session where we will be actually we'll be looking at some of the Python code to show you how you can dissect the data into agriculture sector. And we will look at some of those scenarios on how people are using AI into agriculture domain, right? So that's how we'll structure. And of course, let's spend some time. Dr. Preeti, if you can just interrupt me at the last 10 minutes, we'll keep it for the Q&A sessions.
I didn't get you. Can you please
at the end, maybe we can keep 10 minutes or so for
I will communicate you the 10 minutes at your session.
Great, thank you. Okay. So we just discussed, right? I just given you one example of how sectors like AI or RPA would probably introduce some new sector of new jobs which never existed before. Right, so there will be some job loss, there will be some new jobs. So, but that's how the world evolves, and we should accept. Now, you might have seen the term called data analysis, data visualization. I think they are all relevant as a precursor to AI. Whenever we deal with any set of data, the data needs to be cleaned. Data needs to be properly captured. Just like statistics, right? If you want to apply some statistical model, of course, your data needs to be clean, right? If you throw garbage data, of course, your prediction would be garbage, right? So that is, in a computer science term, they call it GIGO, right? Let me put it this term here. GIGO means garbage in, garbage out. So if you give garbage information to computer, it will predict the garbage prediction, right? So handling the data is very important. So let me tell you a little bit of perspective that when you deal with or when you want to work with any machine learning based problem, what kind of skill set that engineers would need, right? So this is one of the examples that I wanted to, one of the facts that I wanted to share with you. That there are many programming languages, right? I'm sure you know about C, C++, Java, PHP, Python. Interestingly, this is the data for last from 2010 till end of 2018. This is published by Google Trends and was published in Economist. I find it very interesting where Google knows everything, right? These days, if any developer hit any issue, if he comes with some error, people literally go to Google for first to find out that if somebody else has faced this challenge, Google would usually help you out with some potential ramification. So Google pretty much knows that what people are searching or what people are looking for. So based on the people, so this is probably one of the, I guess, reliable metrics that Google has seen that from 2010 to 2018, Java was quite popular. Java is constantly losing its market share, and Python is gone up from third or fourth to number one. That's the Python is the only language, I would say, which is on a forefront of solving data analytics problem, artificial intelligence, machine learning problem, deep learning problem. Python is a default choice. Python is open source. Anybody can learn. It's free of cost. In fact, in our organization, we would have worked with more than 700 to 800 students or professionals in the last few years to get them, many times they wanted to switch the job, switch the function, for example, from mechanical engineering or from, from civil engineering wants to get into computer science, or many of them wants to, they are chartered accountant or CPAs, but they need to have these skills because Python is not that difficult to learn. Even many non-technical people can easily pick up the Python, and I'll tell you why. Why I'm even talking about this. Forget about other countries in the world. Our India itself, Python has been now introduced in 10th grade, 11th grade, 12th grade. In CBSE board, Python is the default subject in computer science in 11th grade. Many schools in many parts of the world, they're introducing Python from the 6th grade. So you can imagine if the 5th or 6th grade can pick up the stuff, I'm sure anybody else, even agriculture engineer can also pick up this stuff. It's not that difficult. And Python, as I said, free and open source. The only closest language is R. R is, I wouldn't say it's a full language. It is more graphical user interface for statistical analysis. For those who are in the statistics background, they know this very well. R or SPSS, there are tools to deal with the data. Python not only has a graphical interface, but is a full-blown computer science computer language, which handles the data very smartly, very powerfully. For example, Excel, Microsoft Excel, if you have 10 lakhs rows in any file, the Excel would die, right? It won't be able to handle. It's even its official Microsoft limits that how much data you can process in a one Excel file. Python can do that in a matter of seconds, which would, Excel would die when you want to draw a chart with 10 lakhs rows, things like that. So for AI ML, I would say for deep learning problems, Python is the only language. That is the reason for this so much of popularity. At the same time, there is a language called Go language, which is developed at Google, which is also going to take few benefits from Python and few benefits from C, but it's still 7-10 years behind. So that's one. Second important skill that someone should learn or develop if you want to work in a data domain, it's business intelligence, right? Microsoft has a product called Power BI, Power Business Intelligence. There is another solutions is quite popular in the market in enterprise sector called Tableau. So these are the tools for data visualization. See, when you have massive data in Excel files or in the annual reports or in whatever in a database, it's useless unless you make some decisions out of it. Unless you write some queries and then get the output. What I intend to show you in the second half of this session is to we looked at India agriculture data, which is publicly available on the various government sites, which includes the rain data, temperature data, India's GDP data, wheat production, rice production, almost 32 different crops, and across India in all different states and union territories, that the production of different crop over a period of last decades. So we have all that data. Now that data would remain in Excel and it could be very boring, and humanly it is impossible to digest that data and get some conclusions out of it. So of course people use Excel, right? But Excel is very time consuming, right? Because once you do it, if any chart you have to change, you have to play around with Excel and you need expertise. I wanted to show you that something with Python. that how you can handle this agriculture data. Of course, I know that you don't probably know Python language, but the objective is to show you that what these languages can make it possible for us. So whenever you deal with any IT person, you know what is possibilities in front of you. Similarly, this business intelligence, that's very powerful, that how you make your data speak. See, jokingly, many times, we've seen in Bollywood movies and, like villain torture, somebody, and then once person is tortured, basically to want the person to speak or want to reveal something, they threaten it with the torture, right? Similarly, jokingly, one of the famous data statistician has said that if you torture data enough, data would reveal the truth. In other words, you must know these different tools and techniques like Power BI, Tableau, advanced Excels, statistics, machine learning to dissect your data, because data has so much of knowledge in it, but you need to extract and get the value out of the data. So this Power BI, the business intelligence tools are, first of all, very useful to get the real-time analysis. See, when you draw an Excel chart would tell you whatever the X and Y data, tables that you given. But what if I want to do what if scenario? Instead of that chart, I wanted to see that instead of 2018, I wanted to get 2019 charts. Then I have to draw another chart for 2019. Basically, I cannot interact with the data, right? And that is what this new terms of business intelligence, which lets you dynamically play around with the data, that is called real-time analysis. And that's why a lot of new dashboards are designed. So those dashboards will tell you a lot more about the different data, and so that you can apply different AI analysis based on the problem that you want to solve. See, bar chart is there for centuries. This is actually one of the charts published in 1781, right, which we're still using today. So nothing has changed. Instead of drawing by hand, where we are having computer to draw it or Excel to draw it, but after all, it's a old wine in a new bottle. But interactiveness is what is important. For example, I wanted to find out that for a given crop, which are the top 3 states? Which are the top 3 states which produce the rice, and which are the lowest, the bottom 3 rice producing states? Or what if I want to find out that is there any relationship between education of a farmer and crop that he produces, right? So there are so many things that can be done as a part of research, which I'm sure you guys would be doing it back of it. But these are the tools like, Tableau, that one that I was talking about, Power BI, there are different tools from Oracle, SAP, all are available to help this. Another interesting angle that I wanted to highlight that, see, whenever we talk about statistics, mathematics, coding, the non-IT people get nervous, right? Because they've never done any line of coding, right? The base they can handle is Excel and PowerPoint and things like that. What if I tell you that there are tools are emerging? This is one of those tools, KNIME, K-N-I-M-E. KNIME is an analytics platform, which we have. We are one of their lead partners, and KNIME kind of tools are again open source, where you can do most of the stuff for free of cost, and they are literally drag and drop. That means if I want to read a particular Excel file for data analysis, I can literally drag a CSV reader, right? So this is some KNIME dashboard where I can drag CSV reader, and I can drag one of the Excel file and connect it. As soon as I connect that Excel file, this CSV reader is a ready-made node available, which would read all that Excel file, and it will tell me how many missing rows are there, what are the average values of it. So I get complete analysis of it. Then I wanted to do some data cleaning, and then I want to draw some charts. I can drag some bar chart node, then I can connect this node, and I can configure that I want to draw a chart for rice production last 10 years, right? Something literally drag and drop. You don't need to write a single line of code, and that it will produce a bar chart. I can click on it and I can say, show me the chart, it will show me the charts. So my point is that without any coding, you can do some various data analysis. So this is probably not many people knows about it. This is getting very popular in European circle, and we have proposed this to some of the universities to include as part of their curriculum, because this gives you a lot of power. Without coding, you can still do a lot of analysis, including even some of those machine learning algorithms. For example, logistic regression. Whether I wanted to do some analysis whether this email is spam email or not spam email, or this particular image, does it has a disease or not disease, right? That kind of problem statement can be addressed without much of course, you need to learn these tools properly, but it is much easier than doing full programming. So now let me take next few minutes to explain how actually it works. So I'm going to make it very simplified, right? Very simplified version of it, so that you get the essence of it. Basically, any artificial intelligence based machine, what does it take? It takes the data as the input. The data could be coming from Excel data like rice production data, or the Excel spreadsheet you have last 100 years of temperature and rain data in a particular territory, or it could be images which has the drone, like drone or robot has taken from the field. All of that can be the input to your artificial intelligence, and artificial intelligence is nothing but our statistical and mathematical software programs which produce the output. And what could be the output? Output could be the action. It can say that, okay, this is a disease, or it can ask robot to move forward, or it can produce some text such as what could be the rice price going to be, or what would be the wheat production is going to be next year in Punjab, for example. So AI is taking the input and then produce the output. Internally to AI, what are the different terms are relevant, like machine learning that we talked about before. Deep learning deals with the images and the text. NLP is one of the discipline of deep learning. NLP stands for natural language processing. Just like I'm speaking with you and you guys are listening to me, right? Whatever I'm talking, you are able to follow me, digest it, and आप उसका कुछ यूज कर रहे हो, आप इंफॉर्मेशन आपके ब्रेन में रजिस्टर कर रहे हो. That is NLP, like natural language processing by computers. Similarly, computer vision is about computer processing the images, just like YOLO example that I talked about earlier. In a visual form, AI is superset, is nothing but the science or is the techniques or framework through which we can teach machines to mimic the human behavior. And how to do it? That is how we do it with machine learning. It's a subset of AI technology techniques, use statistical methods to enable machine to improve its own experience or its own predictions. And deep learning is even further subset of machine learning, which is basically use different neural networks for problem solving. Now, this one particular chart at very broad level would probably make it very clear about how actually it works internally. And this is applicable to all, more or less every machine learning algorithms are behaving in this approach. There are two things involved. One is training and other one is testing, or training or testing or prediction. So one aspect is training. That means using various data or images, I will tell or I'll teach the computer that, look, when you see this kind of image, label that as a non-disease. That means it is normal leaf. But if you see this particular image, where you actually going to feed the image to a computer, and then you telling computer that, okay, this is fungus. But when you giving another kind of image, which is a black color dots, then you call it this is A, for example. Same thing with the radiologist, like human COVID, whether a person has a COVID or not, then people go to CT scan or chest X-rays. Then we need the radiologist to tell, because he is trained. He's been trained for many years, that in the chest X-ray, if you're seeing some kind of dots in a particular area, then it is not good. For a normal people like us, we wouldn't be able to notice exactly, but he's trained. Similarly, we have to train the computer to, and how do we train? We give this many images and then classify. We give a label that this is A, this is B, this is no disease, or this is yellow color, this is black color, or this is car, this is truck. So different objects can be trained, and that is machine learning algorithms. So from a given training data, computer would come up with some algorithm which would take this input data and then come up with the suitable mathematical formulas to proceed with your algorithm. So step number one, you're going to do the training. Step number two, what you will be doing is the testing. Now you want to check whether the algorithm that computer has come up with, the machine learning algorithm that you have selected, is it good enough or not? So what will happen that you will give the remaining some of the training data as a testing. So let me give a very practical example. You have, let's say, 90 different images of different animals. Let's keep it very simple, dog and cat. I have 90 total images. Some of them are dog images, some of them are cat images, some of them are lion images, right? Now I'm taking all these out of 90, I'm going to use 2/3 of those images, basically 60. So let me make it. So I'm going to, out of 90 different images, I'm going to use 60 images for training for machine learning algorithms. That means when I'm doing the training, I'll be telling that, okay, if this is an image, this is a dog image, this is a dog image, this is a cat image. So for every image, I'll be teaching, and the machine would be learning based on my training. Now I have still remaining 30 images left, right? Where I already know what are the dog and what are the cat, but I'll be asking computer to predict based on the algorithm that he has developed, that is this image is a dog or cat. So remaining 30 images are used for testing, right? So this is used for training and this is for testing. So out of 30 images, I know for sure that let's say 15 were dog and 15 were cats. But if my algorithm that was developed here has predicted 16 dog and 14 as a cat, for example, right? That means if you would have predicted 15 dog, 15 cat, my algorithm would have been 100% accurate, right? But here, what it did two wrong classification, right? So instead of 2 out of 30, that means 6% wrong prediction. But my model is 94% accurate. I can say so, right? So this is how you, I mean, I'm just explaining in a very layman term, but using this different training and testing technology, we can come up with reasonably accurate model. for many predictions, if 80% accuracy is good enough, then I will accept this model and then I will deploy this model for real-time image detection, whether this particular image has a disease in a plant or not, right? But instead of dog and cat. So that's how ML algorithms are developed. So once your algorithm is fully tested and you are happy with it, you put into production environment where you start feeding the real-time data, and from the model that he has learned, it will start doing prediction. And that prediction would be helpful to you to make your further decisions. Okay. So in other words, you take the data, you apply, training, you use that data to train your machine models, you build the mathematical model, and you deploy that mathematical model to do the prediction in the real world. That's essentially, in a nutshell, at very, very high level, how AI ML works. Now, internally, machine learning is classified into 3 different categories: something called supervised learning, unsupervised learning, and something called reinforcement learning. Again, this is something those who are really deep into statistics, they would probably understand these terms. Like regression and classification problems are supervised machine learning, and the clustering algorithms are unsupervised learning. I'll give you some basic examples of machine learning, that how it works. For example, if I give you an image and I'll ask you, do you see any human faces in that image? Right? Similarly, these days we know that whenever we wanted to recover password on some websites, on some banking, they ask you to tell you whether this image has any bicycle or not, right? Then you have to manually select. And if your answer is correct, then only it will let you continue. Now you might wonder, why would they ask you to do this? Because if there is a hacker, or if there is a machine is involved in hacking the website, they want to make sure that there is a human on the other end. There is a genuine person sitting on the other end. And that is why they're asking you this kind of problem, which is very difficult to solve for a normal human. So just for a security reason. Now, loan applications, whether this person would repay loan or 0 or 1. So that is a loan approval applications. If I give you English sentence and ask you to convert into Gujarati language, that is language translation problem. That is deep learning problem, right? So these are the real problems and what are the applications for that. Now, this is the topic that I was telling you about earlier. I wanted to just tell you that, see, some of those people are saying that, and again, these are some of the estimates that 75 million jobs would be displaced by computer science or machine learning or AI in coming years. So as one, these are some of the various statistics. The robots would take over almost many jobs, almost 50% jobs by 2045. Does that mean that all will be sitting home and doing meditations? No. There will be new jobs. There's almost 133 million new jobs would be created as we merged. So there's a lot of new exciting things going to be ahead of us. Now, just to recap that how machine learning process works. It goes through these simple steps. First, you identify what you want to achieve. Then you gather the relevant data. For example, if your objective is to find out whether automatically how much water should be given to a soil in a farm, that means you need certain data from the soil, right? So that means you have to gather the different data. You have to prepare that data. You have to clean and make that data ready for machine learning. You build the machine learning model, and then you evaluate the model for testing reasons and see if the model is reasonably accurate or not, and then ask model to predict, right? And based on the prediction could be that, yes, on this particular part of the farm, we need to give water for 20 minutes. In certain part of the farm where there is not enough sunlight or there is no direct heat, that means there is enough water is there in the soil. So why to waste the water? Right? So that kind of predictions can be done, and based on that, relevant actions can be taken. So just to go through these steps very quickly, I think that will help to understand the how to approach the AI-based problems. Is first you define what kind of problems you want to solve. For that, what you are trying to predict, what kind of data point you need, all that you should identify. And then you start collecting the data. For example, it could be rain data, it could be temperature data, it could be some data from some government public websites and whatnot, and then you apply. The next thing is, let's say you collected the data. Now you find out, is there any data which is just to be corrected? For example, here there is some missing data. If you have missing data, you either remove that completely entire row, or you try to fix that data by taking average values and things like that. So once you have enough data, then you do EDA, exploratory data analysis. There is a data analysis term where you start trying to find the patterns and trends into the data, right? That when you look at number of images and you find that most of these images has yellow shade in the leaf, then you talk to the expert and you figured out that, okay, that means either water is less or a particular disease is emerging. So you start doing this analysis, and that is where you start teaching the machine learning model, and then you build the model and then you apply to real world problems. Right. So again, as a summary, you use the training data to build the machine learning algorithm. Then you build that model and you deploy that model with the real-time input data, and machine learning algorithm would do all kind of predictions. And your predictions are not good, then you go back to retrain your model to improve the accuracy. Right? So this is a kind of a feedback loop, and this is how AI/ML works. In reality, there will be lot more details. This is probably at only 5% of broader explanation on how it works. Right, as I said, the basic difference between supervised learning and unsupervised machine learning is here you tell the computer with the label that what kind of data that I'm sharing with you. In unsupervised learning, you just give the data and let computer figure it out itself. Because sometimes you just don't know what are the labels of the data, but you want to just classify them in a separate categories. For example, I have, let's say, 10 million people data, and I'm the travel agency company, and I want to run some travel campaign for, since there is a summer coming up in India, there is going to be vacation season in schools. So a lot of people would be going on a vacation, and I want to target a specific family or specific people for a specific travel plan. See, some of the people would enjoy the beach and mountains. Some of the people would enjoy 3-star, 4-star hotels and just food. So everybody has their own definition of vacationing. But if I want to run the campaign, I want to target to the right people. So I don't want to, the people who are absolutely do not like nature, they like hotels culture. I don't want to, pump the Himalayas and camping trips to them, because they are the more of a city culture people. They would not enjoy the Himalayan struggle and hiking and stuff like that. So why would I waste a massive amount of my printing cost and brochure cost when I know that people are only relevant or interested in these particular patterns? Or same thing with the farmers, right? It depends upon their past history and patterns. I can classify different people in the different groups. And then I know that if Mr. X or Mr. Sumit or he just purchased the Titanic movie to watch online on the Netflix. After watching the movie, the machine would automatically give a lot of recommendation. That if you watch, or for example, if you watch, Piku movie with Deepika Padukone and Amitabh Bachchan, and then you saw another movie, the machine would automatically start giving you predictions that, okay, people with a similar interest would more likely to watch this kind of movie, right? Amazon does all the time, where they will give you recommendation that if you have purchased this kind of books, looking at your history, they will give you recommendations that what is other likely books that you might see. Okay, so that is all about clustering algorithms or unsupervised learning. So essentially in unsupervised learning, it is based on finding the patterns in the data. And after learning the pattern, model can make conclusions. Versus in supervised learning, you have very clear mapping between input and output. Basically, you have to give a lot of training in that case. Right. So if I want to classify particular text, whether this particular text is a abusive text or this is like a very friendly text or not friendly text, right? So that classification can be done by machine learning. If I want to predict the price of the stock, or if I want to predict the price of a particular agricultural commodity, that is a regression problems, which is called supervised learning problem. So this is a good summary of it, that what kind of problems are supervised learning, classification and regression. For example, score prediction, stock price prediction, risk assessment, all they are regression problem. And the fraud detection, email spam, image classification, whether this particular plant has a disease or not, this is all supervised learning problems. Versus facial recognition and all of that, city planning, biology data, that I want to cluster particular data in a particular way. This is called unsupervised learning. And reinforcement learning is largely used into gaming sectors, which is probably a bit out of the scope for today. But that's how the machine learning works. Now, there are some limitations of machine learning, right? When you deal with a large data, such as your human face, right? Human face has so much of data. For example, eye color, hair color, length of the hair, the specs or not, the shape of the nose, the color of the skin. When you have more than 10 parameters, again, this is a general thumb rule. When you're dealing with more than 10 different parameters, you better apply deep learning, because deep learning would be better solved when machine learning algorithms are not able to give very good predictions. So that is why image and text are better solved with deep learning problems. So as I said, it is inspired by our brain, how our brain functions. And when you look at this kind of image, our brain instantaneously classify that as a cat. But internally to a computer, it goes through number of series of steps. And that is what this deep learning is all about. It works like neural networks internally. Let's not go into too much detail, but I'll tell you some of the applications that's solved by deep learning. Okay, so this is just a basic operations of how deep learning internally works inside the computer by different weights and statistics. But these are some of the applications, right? So if this image is taken, right, now you might think that this looks like a dog or this looks like a cat. You're not sure, but based on this image and historical learning, this is how computer would be able to predict and then tell you exactly that no, this is not a cat, this is a dog. For object detection, this is a very common, that this is a laptop, this is a bottle, this is a cup, this is a handbag. Whenever you wanted to do this kind of object detection, deep learning is relevant. Similarly, human-like voice generation, right? I want to generate the voice for a given text. That is deep learning problem. And I'll tell you something which you find quite fascinating, that there are companies are already offering solutions, and I can also demonstrate to you where if you just give an image, just give some image of a particular New York Statue of Liberty, or maybe some traffic jam at railway station, near railway station, right? If that is the image you've given, and within a seconds, computer can write a novel or write an initial couple of paragraphs which describe that whole situation, right? So that is artificial text generation is already a reality. So these are some of the applications of computer vision. Okay. Let me just to explain that, I'm going to play one quick video. I think that would give you very excellent idea about what are the image processing and text processing algorithms can be used. And this is some of the work that Google has done many years back, I mean, in the recent years. But yeah, I'm going to. Can you confirm that you can see the screen?
Yes, yes.
Yeah, okay. So let me just interrupt for a second. Here we are just, the user is just typing that show me the episodes where Michael adds tequila to something, right? Now, this is probably one of the very popular TV show where they're talking about cooking, right? And out of 20 or 30 odd episodes, each of 1 hour, if I wanted to grab a particular scenario only, so I'm just going to type. Now, if you have to really do it, ideally you have to sit down and see all the 30 episodes and watch each and every scene. And then whenever you find tequila, wherever you capture those scenes, and you need a Photoshop person to do that for you, right? So from a large data set, I wanted to identify a particular pattern. This is what the power this deep learning algorithms would offer. So basically, out of this many episodes, in a matter of minutes, the computer would come up with a 1 minute clip, which satisfies all your requirements, right? Automatic translation in 100 different languages, right? So if you have a particular movie clips or particular text which is written in English, you want to translate into 800 different languages simultaneously. That is also possible. Right? So this is the power we're talking about. I'll give you one simple example. Let's say Amul Dairy. Again, I'm just giving this as a plain and case example. Let's say people are watching a particular episode on a Netflix or Amazon Prime. Let's take an example of Piku. In Piku, Mr. Bachchan, Amitabh Bachchan had a constipation problem, right? That he and Deepika Padukone being his daughter, there were many dialogues. So in the movie, let's say Amitabh Bachchan is seen as a applying butter on the with a knife on the piece of a bread. Now you are watching that movie. Somebody else is started watching the movie half hour later, somewhere in Odisha. Somebody is watching that movie in US. Now, if Netflix has a contract with Google, and Google has a contract with Amul as a brand, Amul wants to promote his butter brand. And of course, they must be spending crores of rupees on advertisement everywhere. This is one of India's leading cheese and butter brand. Now, if somebody is watching the movie where Amitabh Bachchan is as a part of the movie scene is applying some kind of butter, at the same moment, if machine learning algorithms are able to detect that at this movie scene there is some kind of a butter and bread is being visible, at very moment Amul advertisement would come up on the screen dynamically. There is nobody's inserting that ad, right? If Deepika Padukone is wearing some jewelry in some movie in Bajirao Mastani, for example, at the same time Tanishq advertisement would come for the jewelry, right? So that is the new possibilities. So even for agriculture sectors or other sectors where when you want to promote your brand, right? This is a new way of handling things, right? This will be revolutionize a lot of media industries and new way of promoting your products and advertising. So that is the application of what we just saw, right? Those are the applications of NLP, language processing, as well as computer vision. Both are combined, right? That's the deep learning possibilities. In reality, it actually, see, whenever I see somebody's face, I immediately recognize that this is Dr. XYZ, or this is Jaydev, or this is cat of the neighbor, right? Our brain instantaneously does it. Computer has to go through a couple of layers of processing, and with innovations in algorithms as well as a super high processing power available in our laptops or in our mobile phone, deep learning is now becoming more and more reality. I'll show you one or two more examples of it. That let's say I wanted to give labels on a street scene. So this is the input, this is the output I would get. If I have a black and white image, I want to convert it to color. So actual image is like this, and it will automatically would come up with this natural color because it knows this is a plant, and that's why it has to be given green color. It will automatically identify this is a butterfly, so it will give some natural colors to it. If you're given this image, age is just age, it will identify this object and it will come up with the real photograph. So this is the input, and machine learning algorithm would give you this image. So this is all kind of possibilities around that. Remember I mentioned earlier that somebody is doing the wrong pose. You will able to identify that which pose is not correct. Text generation is another NLP that we talked about. The chatbots, right? We know in a banking or in various websites, even in 24/7, you have somebody is talking with you, right? How can I help you? And you ask some basic questions, it will able to answer most of the questions. And if he cannot, then it will automatically pass your conversation to a real person, so that very few people can serve many people. Because earlier what happens that if you have 10 people in a customer care department or on a calling center, the 10 people can only serve 10 people, 10 customers. And if you have 50 people calling, then remaining 40 has to wait in the queue. Right. Now, with chatbots, you can serve so many people, right? So that you can give better customer service like that. We have developed one of the chatbot for one of the hospitals where complete appointment can be done without any human need, right? Based on our various question answer, it will give you the appointment for a particular doctor, for a particular specialty, and you will automatically get the SMS or WhatsApp message confirming your appointment, right? There is no human involved. So that is kind of applications are possible. Okay. Now, let's, you go to your Google, right? Go to your Gmail, and Gmail does a lot of filtering. So all the stuff that you see in your inbox is only the useful emails. Google automatically or Gmail automatically discard or automatically move a lot of those spam emails that you don't see. Otherwise, if you're seeing every email, then your mailbox would be filled, right? So Google does give you that experience automatically. Then there's a lot of logical regression, machine learning is used to decide whether this email is a spam email or not spam email. These are some of these other examples. Like, if you give this blurry image, if your image is not clear, machine learning can create this image for you. If person is, for example, if this is a criminal, right? Many times criminal do all kind of different hair techniques, coloring, they apply specs. So if you have, these are the criminals, and the computer deep learning algorithm would produce all kind of possibilities, that how this person with mustache, without mustache, with specs, with hair, color head, non-color head, all of that can be produced in a matter of seconds, right? And that is very helpful to identify the criminals. This is another classic example of deep learning in medicine field. One of the biggest problem in diabetes is the eyesight. Usually the liver, the kidneys, eyesight, and the foot. These are the three organs which is usually get damaged for a sustained long-term diabetic person. The most difficult one is the eyesight. There are extremely very few doctors who are specialized to detect retinopathy. Retinopathy is basically the conditions which is developed because of the diabetic eye. So Google has and a couple of companies has used thousands of images and developed the algorithms which just by taking a eye scan or eye photo, it immediately tell you whether the person has a retinopathy or not. And that is very helpful, because rural places, many times lots of people are losing their eyesight, or they live with a very poor vision for decades because they don't have access to the right expert, which is only available in the large city and also in very few. So Google is now working with many rural places or governments across the world, where they're deploying those machines, where a person can come and just get your eye scanned, and within a second they will get very proper recommendation. At least they will start getting some basic treatments which can solve long-term problems. Okay, so let me pause here and to switch. I wanted to show you some examples of one second. The agriculture data analysis that I was talking about. me close some of these windows. Yeah. Now, this is one of the piece of code that written in Python language that we talked about earlier. See, the data analysis, getting the correct data, analyzing the data, visualizing the data, get the data clean. These are the all prerequisites for applying machine learning algorithm, right? As I told you earlier, remember the term that I told you about GIGO, right? Garbage in, garbage out. If you throw wrong data, your predictions would be wrong. So this is a piece of code that our company has written just to analyze the agriculture data of Indian government or Indian data. Let me just give me a second to show you what the real data looks like, so that you will have better appreciation for that. Yeah. So let's say there is a data set that we have collected from different locations. So this is, let's say, temperature data. I hope you can see the screen, and I'm going to open that.
Yeah, it is visible.
Yeah. So let's say this is the temperature data from 1901. This is January average data in the country is India, and this is data till 2016, right? How many rows? Total 1300, 1400 rows. This is average temperature for a particular month, basically January to December, right? From here you can see. And this is 2016 data. So we're going to take many such data and feed that data into a computer to do this further analysis. So for example, this is fertilizer data. The fertilizer data, which is basically in Andhra Pradesh, gross crop area, sulfur, urea, aluminum sulfate, nitrogen, phosphorus, potassium. So this is basically the quantity, the real data, which is, let's see how many rows we have. Right, so this is overall basic. I mean, you see the different states, Manipur, Odisha, Punjab, the different data set we have for the fertilizer. I'm not going to go through all, but just want to give you some the literacy rate data, where we have captured the education status. So this is Uttar Pradesh, number of total the literacy, and there is a lot of other data about how much they have studied till class 5, class 7. Okay, let me, yeah, that was image overlapped in the data. But yeah, so how much the basic education level, class 5, middle class, secondary class, higher secondary, technical diploma, graduate. So this is every state-wise literacy data that we have. And you can see that the different data that we have about family size, GDP data, livestock, machinery, certified seeds, so on and so forth. And now we want to analyze this data for some kind of a meaningful data analysis that you can further apply for different machine learning algorithms later on. Okay, so this is the Python code. Obviously, I'm not expecting you to understand. Our objective is not to teach you the computer science and machine learning in the Python language, but this is how it will look like. I'm going to I'm running that data literally in front of you. The different Python libraries are used. These are the different data set that we use: temperature, precipitation data, crop production data, literacy rate, livestock, machinery, family size, age group, certified seeds, how many are using certified seeds or not, education, and fertilizer. This data, all this file that we just saw, right? These are the Excel file or the CSV file. We are reading that, we are writing a Python code to read that data and do further analysis, right? So I'm just running the cell, and this is just quick summary of that data of, and here we are just printing top 5 rows. If I just give 10, it will show me the 10 rows, right, from that Excel file. This is Andhra Pradesh, Arunachal, Assam, Bihar, Chhattisgarh. Basically, there are 35 different columns, and I have the data points of that data. This is a GDP data for every state. Okay, this is a GDP data for every state, and data is in crores of rupees. Similarly, this data is India total data, GDP in US dollar, as well as what is the total growth rate from 1961 onwards. Right. So from this is just doing that right here in front of you. So here I got last 10 years of data that I put. So I'm not going to run each and every cell, because that's not the objective. Objective is to just show what kind of analysis you can achieve with programming like this. And that is a precursor for all the AI ML work. So this is 1901 till 2016. Remember, I showed you that data in that Excel file. This is how I immediately summarize that. It go through the entire file in a matter of seconds, right? So I just read this data file, and then I told that give me the all unique years for the data present. This is a precipitation data, which is basically water released from cloud in form of rain and freezing rains, or all that data, which is also I have for many years. This is total crop production, right? And I'm printing the top 50 rows here. So Andaman Nicobar, this is a year in which the data is gathered. This is the season, Kharif, or whole year, or which crop is this? Is the rice, banana, cashew nut? What is the area and what is the total production? Right? All. So I want to find out that what is my total data looks like. I can say right. This is described just like those who are in statistics, they will immediately realize what I'm talking about. For entire data set, in a matter of half second, I got the quick summary of entire data set. That total, how many rows I have? I have 2,46,000, almost 2.5 lakhs rows is there in that CSV file. And I got the complete summary of it, at least for numerical fields, right? The total production, total area, total crop. This is important, right? How much area was, mean value, standard deviation, all that max and mean values that I'll be getting out of this. But important is I have almost 2.5 lakhs rows in my data set. And I want to find out whether do I have a wheat in that data set. The answer is true. Here I want to find out that in my entire data set, because data can have all around, right? So I wanted to find out what is the minimum year and maximum year. So by just running this command in Python, I would know that my entire data set is ranging from 1997 to 2015. Total unique crops I have. So I have 124 different crop are available in my data, and about 646 different districts across all the state. So this is literacy rate data that we're capturing. So I'll skip all of that, but this is livestock data, machinery data, family size. So here I'm getting the data about in Uttar Pradesh, how many families are with up to 2 up to 3 people, up to 4 to 6 people, from 7 to 9 people, 10 to 12, so on and so forth, right? This is a family groups are living together. This is a certified seed data, right? So here we have produced how much certified seeds are used in a different states. Fertilizers, education status detail. Now here is what I wanted to summarize, that so far we have just showed that different data has been captured. Now let's look at some analysis. What can we do with it? By writing this simple piece of a code, I can produce this kind of charts. Out of this, half of these lines are just for labeling, right? For example, this line is just showing the title of the chart, temperature and rainfall over the years. Some of the lines are only for X and Y axis label. The real substance is very low. One of the beauty of Python is your code would be literally few lines of code and will do amazing things. For similar kind of work, if you want to write a Java or C language code, you have to write easily 300, 400 lines of code. In Python, you will be done in matter of just few lines. So here you can see the data from the actual data that we read in Excel file. I'm producing these charts here, that from 1900 till 2020, for almost 120 years of data. On this side, I have a temperature data from 21 degrees centigrade to 27 in Celsius. And here rainfall data from 40 to 180. This is average we are talking about. Average data we have present here. So this line shows average temperature and this is showing the average rainfall, right? I wanted to see if I wanted to see that is there any correlation between GDP? Again, this is, there may not be, but just for sake of it, it's just few lines of code I wanted to present in last 70, 80 years from 1960 till 2020. Is there any correlation between rainfall in India and as to anything to do with the GDP of the country, right? So that both can be plotted side by side. Here we are looking at education, right? So one of the data we have is the literacy, illiterate, somebody studied up to class 5, middle school, secondary school, senior secondary school, technical diploma or graduate. So this is just a title that we wanted to give and we are plotting this data. So in this chart, if you read that Excel file, it won't be useless. It will not be that much of helpful. In Python, tomorrow, this data is for, let's say, till 2018. Now, let's say the government has produced another 2 years of data for 2019 and 2020 or 21. Last 3 years of data is available. You just need to change your Excel file to the new Excel file. Everything else would run as it is. So entire piece of code that I'm showing you, in a matter of seconds, it will produce the new chart, which includes last 3 years of data, right? So this one is showing, this dark blue color is graduate and above. Here you can see that Uttar Pradesh, like Maharashtra, has the highest level of graduates compared to entire population, right? So this is, you can analyze this. Now, here let's look at some real analysis. That I wanted to see the fertilizer applications on a different types of land. So basically, irrigated land and non-irrigated land. Basically, those who are relying on completely on a rain, that is a non-irrigated land. And I wanted to see the results. So quality of applied fertilizers on an irrigation land that is produced based on this simple line of code. So this is what I produced. This is on a irrigated land where you see that nitrogen, phosphorus, potassium, aluminum sulfate and whatnot. And then similar data we are producing for a non-irrigated land. Now here you can immediately see some of the observation that people have to increase the usage of NPK fertilizers as well as ammonium sulfate on a unirrigated land. See, this is unirrigated land and you see that NPK This blue color is showing the potassium. Now look at this. On an unirrigated land, they have to use more compared to the previous one. See, this is less. So those who are with irrigated land, you will be using a lot lesser than non-irrigated land. So that kind of observation. For example, here we look at the farmyard manure, and you wanted to see that applications of manure and pesticide on irrigated land versus non-irrigated land, where you can immediately make some observations by looking at these charts that farmyard manure is often used by people when they have non-irrigated land, right? So as you can see here, the farmyard manure is commonly seen in an unirrigated land environment, but it's completely missing. It's basically not existent into irrigated land. Again, you guys probably would be able to correlate things much better, but as a data scientist, you know, some of the stuff would be very relevant. Here we can clearly see that total region of agriculture in terms of land, right? So top agriculture region in terms of land in 2011, it is Punjab, right? Punjab, Gujarat, UP are the top in the list. Similarly, if I want to find out the top crop in terms of production, right? So you can immediately be able to generate this chart dynamically. You can clearly see the sugarcane and coconuts are on the top on the list. Now what?
Mr. Nikhil?
Yeah.
We are left with almost 5 minutes. So
sure.
Can we take the question from the audience?
We'll switch the question. Just give me a minute. I'm just wrapping up this.
Yeah.
So here you can see that total wheat and rice production, but more importantly, I wanted to show the dynamic nature with the visualization. See here, I can create this kind of just from a data with simple line of code. I wanted to find, I can select, let's say rice. And then in a rice, I can pick the different states from here. So let's say West Bengal is probably, so as soon as I select, the data changes here, right? If I'm Uttar Pradesh, the data would change. So this dynamic interactivity with the data in Python can be done completely free of cost. Of course, you need a Python knowledge. Here, Goa's rice production, does it has any relationship with the rice production of a particular state compared to the GDP of that particular state, right? So we have taken GDP of that individual state and the production in every state. So here you can pick all these different fruits. And similarly, the area which is used for a particular crop production. My point is, using this kind of analysis, you can further use this analysis to apply machine learning algorithm to do the prediction for different rice in next 5 years, right? Things like that. So with that, let me stop here and let's switch to the questions.
Yeah. So thank you very much for taking this session. Let me take a question from the audience side. First one is, updation of the data or text processing is necessary, for example, for weeding problem. If we are using AI, if some new weeds has come up whose image is not in the AI system, that would create a problem.
Great question. How does human would do the same? You also need to be trained, right? You need to constantly upgrade yourself. So there are easier ways to classify those things, right? So yes, the short answer is yes, you have to upgrade your learning along with it, and it's not difficult.
Yeah, we need data by any way to predict anything.
Correct, exactly.
Yeah. Next is, I think, sir, first of all, to make this technology popular and extensive, practical training is required. So you're explaining very nicely, but when it comes to actually using, it won't work very efficiently. Yeah, so actually this is a very genuine feedback from the participants, and We as an organizer, even our speaker, Mr. Nikhil, also appreciate your concern. But we have some limitation at our end also, because we got registration from heterogeneous group, right? And some of them are very much aware of these things, but many of them who are from core agriculture or horticulture background, it will be really difficult for us to straight jump into the technicality without giving them motivation why they are supposed to take artificial intelligence or machine learning so serious. So because of heterogeneous groups, first limitation is that, and another limitation is timing also. We are conducting these things for 5 days only, and if you want to enter into the core technicality, then we at least need 2 to 3 weeks to cover up those things. Am I right, Mr. Nikhil? Do you agree with that?
And think about it, guys. If the computer engineer spent 4 years in college to learn different stuff, right? But what my role, our I think organizers' role would be to expose you that these problems can be solved, right? So before we want to run, you have to walk. So for many people, I think it will be very useful, I guess, to start walking.
Because people are also commenting in the chat box, your session was excellent. Maybe because they are totally unknown and they wanted to know, they wanted to familiarize with such kind of concepts. So yes, it is useful. And with respect to concern of that participants who have given that feedback, I suggest you to follow Nahib site and our upcoming events. We are going to start one of the online self-paced course, which is on data analytics through Python, which is of 3-month course, self-paced online learning, where you can have background of basic of statistics and also most widely used statistical techniques. Some of them are from machine learning, as well as we will cover neural network also in that course. So you will have understanding of theory as well as practical through the Python software. So if you wanted to know the technicality part, follow the Nahib site and register on that particular course also. And if your concern is to know the technicality of, robotics or IoT, then we are actually planning come up with such kind of event in future, where you get to know the idea how these core engineering part of IoT will work. So this is all from being organizer from my side, if you want to follow that. And next question is how we can get funds for any ML project. So Mr. Nikhil, would you like to add something? Yeah.
Well, it's quite open-ended question. Just like many startups in Gujarat or across India, I think government of India is quite, I'm highly appreciative of many programs going on. If you have a great idea, you partner with technologists or relevant people, and there are from 2 lakhs to 50 lakhs, all kind of different funds, student startup fundings are available. Specifically for machine learning, there are so many companies. We probably need a half-day session to talk about the different companies has got the funding for different ideas. But yes, there are different government schemes. Probably I'm not the right person to comment on that. But I think most important part is ability to identify the problems, that this problem can be solved using technology, which is many times people have just accepted that this is what it is. Right? There are solutions to do that. That is what you can achieve with this. And I'm highly appreciative of your interest. And as just to add to what Dr. Preeti mentioned earlier, that the first step would be to start learning Python or data analysis. And I'm sure there are so many online programs are available. And if there is a requirement, if there are doubt clearing sessions or you need some help to get starting, please let us know. We'll be happy to work on that with you guys.
Yeah. So if you're actually interested to take some funds from any of the organization, first start searching what is the real life problem, and you will certainly get funds from even government organization also, and other people are also giving funds for such kind of projects. So next question is, Mr. Nikhil, how to identify the disease status, monitor milk production and cleanliness of a dairy farm employing AI and robotics?
Interesting. So I think if I summarize the question is there any way, is there any solutions to find the quality of milk or cleanliness of the facilities and whatnot? Yes. See, you can apply this algorithm to a given problem statement. So looks like the question raised by a person who is looking for, is there any way to do that? Yes, absolutely. You need to train your machines, or you need to train your algorithm where you have very untidy or dirty facilities versus clean facilities, the object that not supposed to be there, right? So YOLO and many algorithms that we talked about, they will be able to help you to segregate facilities like that. Versus milk production, right? That is more or less milk sensors. I'm sure Amul and many dairies would have implemented those solutions already. But where AI can be helpful is if you monitor the milk quality over a period of last 20, 30 years for the fat quality or particular hormones is getting more and more, that will give you very valuable data where because of the heavy use of fertilizers or pesticide, you probably would see more those substances coming up in the milk. And looking at that analysis, applying to machine learning algorithm to make the future prediction that by which year you will cross the limit, which is not healthy for the humans, for example. So those problems can be solved with that.
Yeah. So I think I'm done with the question from the audience side. And you took this session in a very layman way. And I'm hoping that many of the participants who are totally not from the background of whether engineering, coding, or statistics or mathematics, they must have some idea where this AI part will be useful in their own domain. So thank you very much, Mr. Nikhil, for this simple explanation. And we are hoping your association in future events as well, where we are more inclined to, describe the technicality of artificial intelligence. So thank you for now. And dear participants, we are closing this session here, and we will resume back at 2 p.m. from Indian Standard Time for the next technical session. So thank you for now.
Thank you.
Thank you, Mr. Nikhil.
Thanks.